Students, packet switching की बात start करेंगे. And as I told you in the case of circuit switching, the circuit switching had a data connection that was supposed to be established before the data transfer can start. Once the data transfer was complete, we teared down that connection. Students, we also looked at the fact that there was no packetizing of the data that happened in the case of circuit switching. Students, packet switch networks mein, we normally send this data in the form of packets. Students, when we need to send the data from point A to point B, we actually packetize these data, and the size of this packet actually depends upon what specific layer protocol are we using, and also the network type that we have. Students, the virtual circuit approach that we're going to talk about. This virtual circuit approach, you'll see that this is what we use in the case of data link layer, and the packet size is normally small, and we call it as a frame. Students, in the other type of packet switching, which is the datagram network switching, you'll see that the datagram networks use a packet size which is relatively larger than a frame, and it's called as a datagram or a packet, and it's mostly a layer 3 approach. Now, students, in the case of packet switching, what normally happens is that we don't reserve the resources ahead of the data transfer. We do not set up a dedicated link before the data needs to go from A to B. The bandwidth on a link is allocated on a first come, first serve basis. Students, when a packet is sent from A to B, it reaches a connecting device, maybe a switch or a router, and then depending upon the current state of the link, the packet may or may not need to wait, and if it needs to wait, it is normally queued, and once the congestion is over, once the link is free and the space is available, this packet is then transmitted onto the link. Students, the basic difference between packet switch networks and circuit switch networks is that in the circuit switching, we actually dedicate a link before we transmit. In the packet switching network, we deal with every single packet on a first come, first serve basis. Students, the first type of this packet switch networks is what we call as the datagram networks. Students, the packets in this particular case are called datagrams. And in the case of datagram networks, we deal with every single packet independent from all other packets. Students, even if this datagram is a part of a multi-packet transmission, a transmission that carries thousands of packets, we still deal with every single packet from a routing perspective, from a bandwidth utilization perspective, and from a transmission or a queuing perspective, independently from all other packets that are part of that transmission. Students, the second type of the packet switch networks is the virtual circuit networks, or we call it as a virtual circuit approach. Students, this is the approach that we normally use at the data link layer. Students, virtual circuit approach is a cross between the circuit switch networks and the datagram approach. Why am I saying that? Because in the virtual circuit approach, which is what we are going to use at the data link layer, you actually have to establish a circuit before the data is sent onto the links. Once the data transfer is complete, you actually tear down this link. So a property of circuit switch networks is present in virtual circuit approach. Now, students, in this virtual circuit approach, the data is packetized in the form of frames, and we'll go through that in detail. So this virtual circuit approach is a cross between circuit switch networks and the datagram networks.